Today we're going to be speaking about Featureform 101. We're going to go into a lot of different facets of Featureform and feature stores in general. We will be starting with the problem statement that feature stores solve. We'll talk about feature stores in an MLOps stack, the 3 types of feature stores, and then we'll break down Featureform in particular and go through a quick start. If you have any questions through this, feel free to throw them in chat. If you're following along on LinkedIn or Twitter, you can also leave your comments and questions there. I'm going to give a quick introduction on myself. My name is Simba. I'm one of the creators of Featureform. Featureform was built as an internal project where we were dealing with problems like fraud detection, predicting subscriptions, predicting churn, recommender systems. And we built a lot of in-house MLOps, just ML infrastructure to help us build these models, build them faster, get them in production. One of the things we built, nowadays we'd call a feature store, and eventually we decided to open source that. I personally decided to go full-time and full in on building out Featureform, both as a product and as a company behind it. Great. So let's talk about feature stores. So I want to first just super quickly talk about what a feature is. A feature is just an input to a model. So whenever I say feature in this talk, I mean an input to a model. I don't mean like a product feature. I specifically am talking about inputs to models. If I mean a product feature, I'll say capability. That's how I separate it. So when we started learning data science, like just think back to when you started learning machine learning, you typically start, like I started with these nice CSVs, and those columns in the CSVs would already more or less be the final feature. And so a lot of the focus was on building models on top of this data. In practice, though, as you go into the industry, as you deal with real problems, things are way more complicated. You start dealing with lots of data infrastructure, lots of data pipelines. You're building and iterating on features and training sets and models and notebooks. And it kind of very quickly can devolve into chaos. At least that's what I've seen, and I'm sure a lot of people can relate. The way I imagine this or think about this is if you've ever seen like an untitled, 128, the IPy notebook that you have to run as part of building your training set and training your model, then you know what I'm talking about. MLOps was built to help alleviate some of this pain point. It's a set of tools and practices to automate and streamline the ML model lifecycle from ideation to production. So that's kind of the definition that I give to MLOps. So MLOps as a whole is very broad. There's a lot of different problems to be solved. There's a lot of different tools and components of the stack. One way to think about the different types of tools in the ML model lifecycle is to break it down in terms of the ML model lifecycle. When we're dealing with building and deploying machine learning models, there's really 4 stages. There's the data stage, the model experimentation and training stage, deployment, and then monitoring. So those are the 4 stages. Feature stores specifically focus on the first stage. So feature stores specifically focus on the data part of machine learning. There's kind of 2 parts of this problem of data and machine learning. One part is what I would call the engine problem. How do you serve, some amount of data under some time frame? How do you deal with streaming data? How do you process some huge data sets? There's also the workflow problems, versioning, data analysis, pushing features to production, monitoring, lineage, sharing, reuse, collaboration, governance, and more. I mean, like testing, for example. So those are the workflow problems. So there's engine and the workflow. Featureform in particular is focus on the workflow problem. So we delegate the engine problems to underlying data infrastructure like Redis, Spark, whatever you're using today. We sit above it and solve the workflow problem. That's why we call ourselves the virtual feature store. I'm going to take a moment, and we've been talking about feature stores for a bit. I want to really make sure one thing is clear, because I know this adds a ton of confusion when people are learning about Featureform and feature stores in general. If you hear the term feature store and you knew nothing about what that was, and I made you guess, you'd probably guess it's some sort of database where features are stored. It kind of tracks. That's kind of what the name seems to imply. And for some feature stores, which I designate as literal feature stores, you'd be right. So this is like Databricks' feature store, Google, Feast, etc. Their approach is that you build your features and training sets, and then you just store the features into the literal feature store. Featureform, on the other hand, has a very different approach. So the literal feature stores treat features as like artifacts. They're just tables of data, featured data. Our approach is different. We think of the feature as the definition. It is the transformations themselves that make up the feature. So you will define your features as transformations. That could be in SQL, it can be in PySpark, it can be in Python. You orchestrate that on top of AWS Spark Redis, and that will build, and then Featureform will store the metadata, make it searchable, versioned, etc., and it will orchestrate it on top of your engine, AWS Spark Redis. So that is the Featureform framework. A little more broadly, we call ourselves a virtual feature store. So the virtual feature store approach allows you to use our API to declaratively define your features. We have a dashboard, which you can also use to search things, look at monitoring, alerts, etc., governance. So Featureform itself is kind of the circle here, where it has a built-in resource repository, it has collaboration in it, monitoring and alerting, and governance. It's also orchestrating. So it's building your features, storing them, running your transformations on top of your compute, storage, etc. In the end, the goal of building and all these features is to train your models and then serve an inference. So essentially to get your features in production. And that's a core value prop of Featureform, is to get your models, or your features rather, into production in a way that is very easy to understand, easy to iterate on, etc. That kind of makes up the core of what Featureform is. So let's get into Featureform itself. Let's get into the API, get into a bit of code. So the core concepts of Featureform, we'll start the top layer. Featureform allows you to define providers. Providers are the data infrastructure that actually stores and transforms data. In the providers, you can register your data sets. Those could be tables, directories, etc. From those data sets, you can actually run, or you can define transformations and build new data sets, so like derived data sets. Once you have the set of data sets that you need, you can start designating columns as features or as labels, and you can join those features and labels together into training sets. So those are kind of the core top level resources: providers, data sets, features, labels, training sets. And like I said, the provider is made up of two kinds. There's the offline stores and the inference store. Inference store is about low latency serving. Offline store is about transforming and storing your data sets. The data sets themselves, there are primary data sets, which from Featureform's perspective are read-only, and then transformations, which are the transformations that you define. Cool. So I'm going to show you a lot of different components of Featureform, but actually before I come back to these slides, I actually want to show you how it works in code. So let's go through that. So I'm going to stop sharing so I can pull up my my terminal. Okay, clear this. Okay, so I'm gonna do this. So I have my terminal here. So the first step, and obviously if you want to follow along, feel free to pull up your terminal and you should be able to do the same. You're gonna need to have Python already installed as well as Docker to be able to follow along here. So the first thing we're gonna do is, if you haven't already, is install and upgrade, if you have it, Featureform. So I already have, mine's up to date, so it won't do anything, but I'll give it a moment for those of you who need to install. Now, what we're gonna do here, so Featureform has a CLI tool. It's called Featureform. So if I just write Featureform, it shows up. If you don't have it, so it doesn't show up on your path, you could always just do Python 3 or Python -m Featureform. Give you the same effect. And you could, as an example, you could look up the version, it will print the version. Great. Let's run our quick start. So to run the Featureform quick start, you do Featureform deploy quick start, and that's it. So it's gonna run 3 Docker containers. There will be a Redis container, a Postgres container, and Featureform container. It's also, if you look at your here, you'll see that it also has created some files in this quick start directory, which we'll get into. So first, let's take a quick look at what got deployed in Docker. You can see that I have 3 containers. Like I said, there's Redis, Featureform, and we have our own little wrapper around Featureform, around Postgres that we run, which just has some tables built in so that we don't have to manually copy them over. Great, and you can also see that I have 2 ports linked. There's the 80 port and 7878. So let's take a moment and we'll come back to it, but you'll be able to look at port 80. So if you just go to your browser and go to localhost 80, you'll be able to see Featureform running in the dashboard. So let's run the quick start. So we're going to go into the quick start directory. Let's look at the definitions.py. So as you can see here, first thing I do is import Featureform. I can actually delete this, but because I don't want to explain it right now, but you can leave it if you'd like. The first thing we're doing, like I said, is registering those providers. So there's a Postgres provider and a Redis provider. Both of these are in Docker containers. And that's why the host is host.docker.internal, is because Featureform is running in an internal Docker network, as are these containers. So that's how it's accessing them. Your password and user and everything is going to be the same default. It's running locally in your Docker. It's not an issue. The first thing we're going to do is register a data set. So this would be a primary data set. So a primary data set, you'd have transactions equals Postgres.register table. You would get the name, the table, and yeah, it's going to register in Featureform. We'll be able to use it. The next thing we're going to do, so Featureform supports Python transformations, SQL transformations, and PySpark transformations. So, or data frame transformations more broadly. In this example, because we're using Postgres, Postgres does not natively support data frames. So we'll have to use SQL. So the SQL transformation is really simple. We're going to do a little group by, take the average transaction amount from transactions here being this table. Then we group by user. We create a user class. It's an entity. So an entity is a thing that you can attach features and labels to. So we have one feature, which is our average transaction. It comes from the average user transaction transformation data set that we built. It has a type and it has an inference store. So we're saying that this feature is going to be cached in Redis for online serving. We also have a label, which is the entity ID or entity column is customer ID, and the value, the label is fraud, and the type is Boolean. Finally, we register a training set, which is fraud training, the label, and the features. Cool. So I'm going to go through this again in more detail later, but I want to just kind of give you a sense of this. So to actually run this, we can do Featureform apply. We're going to set the host. The host is localhost 7878, like I mentioned. We also need to set this as insecure. The reason why we set as insecure is because our local one doesn't run, doesn't have a SSL certificate set up when you run it as a local Docker container, because it's meant for a quick start. So we have to just make sure that we don't try to hit it with an SSL endpoint. And then finally, the actual file that we're going to apply. So definitions.py. Now you can see that it's actually now building all these things. And with regards to transformations, it ran it. It then created the feature. It put it in Redis. And then once it had the feature and label, it built the training set. Cool. I'm going to come back to this code, but I'm going to actually show you now the dashboard. So let's go back to sharing this again. You're gonna open up the localhost. You can just write localhost or localhost 80. This will show you all the things you created. So you create a training set called fraud training. You can see the features and labels that make it up. We have these sources, transactions, which is a primary table in Postgres. You can preview it if you wanted to, and you could see what's in this table. We have another source, which is average user transaction. You can see the SQL query, which built it. And you can preview it. So you can see that there's two columns. There's the user ID and the value. And then, yeah, there's training sets. We built a training set. You can look at the features, like we have average transactions, which is a feature. You could look at metrics about that feature. You could go through the lineage and understand how that feature was built, etc. Now, I'm going to break down the code a bit more. So what I'm going to do real quick, I'm going to pause my share so that I can just really quickly copy the code over that we were using. One second. So, well, actually here, you know what I'm going to do is I'm actually just going to do this from scratch. I think it'll be more interesting anyway. So I'm going to resume my share. So I'm going to import Featureform. Import Featureform. I'm going to create a client. So let me just run this and then I'll add this, make sure everything's working. I'm going to create a client. So I'm actually going to import this as FF. I'm going to create a client. So ff.client host equals localhost 7878. And then insecure equals true. That's going to be my client. Just to write a quick test, we can do client.apply. And it doesn't build anything, but you can see that it applied. Okay, now I can start doing more interesting things. I can get some of my data sets. For example, I have that source average user transaction here. I can grab the variant. So the variant is like the version. Everything is version. This is the automatic version. If you don't set one, that's what gets used. So, but I can, going back to here, I can get average user transaction. Or is this a feature? Yeah, it's a source. Average user transaction. And the variant is that. So that will be my source. And the cool thing that Featureform allows you to do, so I can get this, just make sure that works. Everything in Featureform can be transformed to a data frame. I can just do client.dataframe source. Name variant source. I can, so I know I did wrong on this one, but I can actually just copy and paste this here and it will work. And you can see that it allowed me to get this whole data frame or this whole source in Featureform as a data frame. Everything in Featureform is usable as a data frame. Now, the other thing that you're probably going to want to be able to do is serve features for training and serve features for production. So let's first get our training set and you get it in a form that we can use in production. So I'm going to get it as a data frame. My training set is called fraud training, and then this is the variant. So if I do fraud training and then the variant, and I run this, you can see that I now have my training set as a data frame. So I can train on this. So you can see the feature column and you can see the label column. Now, the other thing that you're going to want to be able to do is to serve features in production out of Redis. So this is serving out of Postgres because that's my offline store. But if I want low latency serving, I'll use my inference store. So I can get any feature. So I can go client.features. I can come back here, look at any feature I want, like average transactions. So I can do average transactions. I can do that. This should be in a tuple. And now the difference is I need to specify the entity. The entity is a specific user, in this case, a user, because the entity is a user, that I want this feature for. You can do multiple users, but in this case, I just want one. So I'm going to do user, and then I can just grab any random user, like this one, throw it in here. Oops. And now this will serve out of Redis. It will serve my feature. Hopefully I got all that right. Entity. I probably am just doing it wrong. Entities. So you can see here that I have I got 70 because for that specific feature, as we see here, the value is 70. This comes out of Redis. I can do much more complicated transformations. I can add timestamps to my transformations that will allow me to do point-in-time correctness. There's a lot more I can do here. The goal of this is not necessarily to show you a more complicated use case. This is kind of Featureform 101, but I just wanted to give you a sense of what the code looks like. But with that, I'm going to go back to maybe showing you some more complex examples and showing you a bit more. So like I said, like Featureform, you can register transformations. It's all Python. So you use Python to define things. Everything can become a data frame. The documentation, like in this case, the PyDoc, becomes attached to the transformation itself. So this becomes like part of the transformation and the data set. You can define features and labels. Like I said, you can include a timestamp. If you include a timestamp, you will get correct point-in-time correctness. It's a little out of scope for this one, but it is something that is kind of given for free of Featureform. Everything in Featureform is automatically versioned. We saw that some of those automatic versions. Now, the automatic versions are a sort of a timestamp. You can also name them, which is usually an easier thing to do if you're going to reference them. If you're using objects and passing around objects, which Featureform allows for, then you don't have to do this. But if you want to, yeah, you can just name things if you want. Everything in Featureform is immutable. What that allows for is every single time you build a feature or a pipeline, you know that there's no worries about an upstream breaking your downstream. So someone won't be able to change something and break your feature in production. At the same time, how Featureform works is if I change my transformation, it will create a new version automatically. So when I'm experimenting, what I tend to do is I don't name my variants, my versions. I just keep all the automated ones. Featureform is smart enough to use, if you have an existing one, it will use the same one because it's immutable. And if it's a new one, then it will use the new one. Typically when I use Featureform and a feature is ready for production, I'll name the variant. This will allow me to really kind of pin it. So here's how you would specify a named variant. You just add in the parameter the variant string. So the Featureform dashboard, the version I showed is kind of an older version that we still have attached to the quick start. This is kind of a more recent upgrade of Featureform and how the dashboard looks. This is specifically the enterprise one, so it's slightly different, but more or less the same. You can see that you kind of have this deep navigation. You can see how your resources alerts, how things are going. You can search. Anything is searchable by tag, description, etc. You can do more complicated things like building triggers. So I can have a schedule trigger, which happens on some timeline, and I can attach that to my features or my training sets. And when that trigger fires, it will update my training set and features. They're also searchable, and you can kind of edit them and look at them in the UI as well. You can look at every transformation that was run becomes a task. So you can see all the tasks that were built. The tasks come together to build jobs, which are the job is used to build a feature or training set, and you can also look through those. And you can also understand the providers themselves. You can see how all your different providers are performing, if there's any issues with them. You can look in the providers and see what features and labels and data sets are on that provider, where they're being used, and any other alerts that happen. Alerts can be more complicated, like we support monitoring, where your feature values might be changing dramatically in production. And so alerting allows you to catch that stuff and get a warning before it becomes an issue. Or if a transformation stopped working for some reason, you might get a critical alert. So you can go see what's happening and fix it. Featureform supports 3 types of features: streaming, batch, and on-demand. To figure out and to break this down more, I want to start by first explaining the 2 kind of elements that are affected by these different types of features. There's the freshness and the latency. The latency is how long it takes from the feature to get from the feature store to the model. The freshness is how old that feature was, or when was that feature last updated. A really easy way to get low latency, which is good, is to cache your features, essentially pre-process them. That's the example I showed where you set the inference store as Redis, you're pre-processing a feature. So these are the 2 elements. The other element, which I don't have here because it's kind of hard to show in an image, is complexity, which is just how hard is it to build that feature pipeline. So pre-processed features on the left here are streaming and batch. Streaming and batch features are pre-processed and go into an inference store. That means that the latency is going to be quite low because it's just a serve out of Redis. But the freshness can vary. If it's a batch feature that's running every 24 hours, it depends, but worst case, it's 24 hours old. With streaming features, it could be maybe a couple seconds old, which is good. Batch features and streaming features are better in pretty much every way, except that they are far more complicated to build. When you have problems with them, are a lot harder to fix. Featureform tries to abstract away a lot of this complexity, but in general, streaming features are always going to be more complicated than batch features. Finally, there are on-demand features, which we also support. On-demand features allow you to define features that are actually generated at the request time. That can be useful for two reasons. One could be you need something extremely fresh, like you need to go actually pull it and build it at the moment of the request. The other common, probably the most common time that people use on-demand features is when they are having to featureize data that comes with their request. For example, a user is making a comment or like let's say a review on a product, and you want to do sentiment analysis on it. Well, you won't have the review until the request time. So the features have to be built, the features that depend on the comment have to be generated at request time. So this is another example of using an on-demand feature. So Featureform supports all three. There's slightly different APIs for them. They're not that different. Like here's an example of a streaming one. As you can see here, like it looks very similar. Like the source or data set is the topic in Kafka. The transformation still, in this case, being run on Spark Streaming, looks very similar, except you're using a streaming data frame. And then rather than defining a feature, you define a feature stream, which just has slightly different API, but more or less it's about the same. Featureform fits into much more complicated pipelines. It has governance and access control, monitoring, all these other things built in, and allows from this kind of three-stage approach where you use notebooks and experimentation and a development channel where you're just interacting with Featureform. You are building and transforming, building data sets, building features, trying things out. You can then deploy those things. There's many different ways to do so. Featureform supports like tags. It supports, like I said, governance, which allows you to specify when something is ready for staging. Typically, the feature will be built again from scratch. Validation will be run. This could be like rate expectations. And then eventually it will go into production. And so this is a very common flow with something like Featureform. So that's pretty much all I have for today. I know there's a lot of information. I thought I'd leave some time at the end for any questions that anyone might have. If you have any questions, feel free to throw them in the Q&A. And if you're on LinkedIn or Twitter, you can also throw them in chat there as well. I'll give it a minute for questions. I'll stop sharing. And then Marie, you're looking at LinkedIn for any comments there?
Yep.
Cool. Well, in the meantime, why don't you let everyone know, Marie, like what to expect from here?
Oh, we do have one question.
There's a question of will this be recorded? Yes, so it is recorded, and we will be sending a follow-up email which will include the recording.
Yep. So yeah, after this webinar, I'll send everyone an email with the webinar recording, as well as links to our docs and our Slack community that you can join and ask us more questions.
Yeah, and at any time, if you have any more questions, if there's something you think of later, you can join our Slack and message there. It's a great way to get a response. If you have a question specifically for me, I'm just simba@featureform.com. So you can always just email me directly if you have a very specific question for me. Awesome. Thanks, everyone.